So far, we've looked at graphing and substitution as means of solving for a solution of two equations. Now we have a third method called elimination. And this involves subtracting or adding variables in order to get rid of one. So here's our first example. We've got x plus 5y equals 2, x plus 3y equals negative 4. So we can add or subtract one of these equations in order to eliminate one of the variables. So in both cases we have 1x. So what we can do is we can use subtraction to subtract the x from one equation from the other, which will give us a result of 0x. So we've eliminated one of the variables. Now, if we're using subtraction to get rid of the x's, we have to subtract for the rest of the equation as well. So 5y minus 3y gives us 2y, and 2 minus negative 4 give us 6. So we further along, we'll have 2y equals 6, and solving for y gives us a value of 3. So now we have a value for 3. We can solve for the other variable by plugging that 3 into our equation. So we'll just choose one of the other equations, just like we did with substitution. So we use the x plus 5y equals 2 equation. Plug in a 3 for y, and we're left with a result of negative 13 for x. So now we have a point of intersection, which is negative 13, 3. And graphing it shows us visually the same result. Next equation, 3x minus y equals negative 9, 4x plus y equals 23. Now if we look at the y's, we can see that if we add a negative y to a positive y, then we'll eliminate the y variable. So we'll use addition in this case. 3x plus 4x equals 7x. The negative y plus y gives us 0y, thereby eliminating the y. Negative 9 plus 23. Further reducing gives us 7x equals 14 for a final value of 2 for x. Once again, solving for the other variable, we'll take that 2, plug it into one of the other equations, in this case 3x minus y equals negative 9. Solving for y, giving us a result of 15 for y. So now we have a point of intersection 2, 15 with the resulting graph. So we have to make a decision about whether subtraction or addition is going to eliminate one of the variables. So in this example, we have a positive 3x and a negative 3x. In this case, adding these two together will result in a 0x, which eliminates the x variable. So in this case, we will use addition. Once we have a value for negative 2, we can plug that negative 2 back into the equation and solve for x, resulting in 5. So we'll have a point of intersection of 5, negative 2. So in this case, to eliminate the variable x, I would use addition. In this example, we have negative y and negative y. So by using subtraction, we could eliminate the y variable. Once we have a value for x, we plug it back into one of the equations, leaving us with a value of 1 for y. So our point of intersection will be negative 4, 1. So the general rule is, if you are trying to get rid of a variable, look at the signs of the variable that you're trying to get rid of. If the signs are different, add them together. If they're the same, subtraction will eliminate the variable. So in this example, we have 4x plus 5y equals 22 and 4x plus 2y equals 16. So we're going to eliminate the x's, and we're going to do that using subtraction. Because they're both the same, subtraction is the chosen method for eliminating the variable. Leaves us with 0 plus 3y equals 6, y equals 2. Once again, we'll plug in the 2 for y into one of the equations and solve for x. Gives us a value of 3, so we have a point of intersection of 3, 2. In this example, we'll get rid of the y's and we will use addition because they're different. We have a negative 5y and a positive 5y. By using addition, we can eliminate the variable y. Adding them together, 7x plus 0 equals negative 35, eventually giving us a value of negative 5 for x. Plugging that negative 5 back into one of the equations, solving for y, giving us a value of 1. So our point of intersection will be negative 5, 1.